All right, hello class, Will McBurney here. So briefly, I want to discuss how ImageData.java works. This is something you will use in the final part of homework 8, where you need to be able to analyze an image to extract the pixels in order to extract the bits for the message. And we talked a little bit about that in class today, but what I want to get you familiar with now is ImageData.java and how to use that alongside a two-dimensional array. To do this, I wrote a brief program that is going to take this picture of Will Greer scoring the winning 2-point conversion against Texas last week. Go Mountaineers. I'm going to flip that image over, and I wrote a program called ImageFlip, which uses some image data methods that we're going to take a look at. So first, pretty standard public class ImageFlip, public static void main string args. We've seen this before. What we're going to do is get the input file from the command line. So I need to call this with, image Java ImageFlip, and then the name of the image I want to flip. That image is going to be loaded into a 2D array here. So if I, for example, said Java ImageFlip Greer.png, then that will load in to this image array the pixels of this image of Will Greer scoring that 2-point conversion. From there, we're going to get the height and width in this fashion. So the height of the image is actually the length of this first array. So realize that image is actually a 2D array, or not a 2D array, but an array of integer arrays. And so you could think of it like you have one array. So this is not me editing the code. This is me just making some notes here. You have one array for each row. One array for each row. So for example, then, image 0 is row 0. That is the top row of the image, and image 1 is row 1, and so that is row 2, or the next row of the image, the next row down of the image. And so we're going to have height number of rows, so that is the length of the array of integer arrays. To get the width of the image, well, we want the width of this array, image 0, which is where we get here, image 0.length. We can take advantage of the fact that this image is rectangular, which is to say that every row is the same length of this image. And so this allows us to get the height and width of the image in this way. From there, I'm going to create a new integer array, which is the same size, hence int height, int width of my input image, but it's going to be flipped upside down. To show you what that looks like now, I'm going to run, need to Greer.png, and you will see that there is the picture of Will Greer upside down. So I did two approaches for this, and the first approach I'm going to show you actually is to, and we'll comment out this section, it's to use a nested for loop. And this may be your first instinct as the right approach, and there's certainly nothing wrong with this approach. We simply have a row counter. Int row is initially 0, looping all the way through image.length, which I can actually replace this now with width, or with height, excuse me. And then image 0.length, which again can replace with width. And so the idea is there's height number of columns, or height number of rows, height number of rows, and I'm going to iterate through each row. Within each row, I'm going to go through each column, starting from 0 and working my way to width minus 1, which is the last column, and I'm going to get each pixel, and I'm going to define the opposite pixel of the image. So for example, if row column point to the top left pixel of this image, this will give me the bottom right pixel. If this points me to the top right pixel, bottom left. It's just getting the opposite pixel, and it's setting that pixel right here equal to the opposite pixel. From there, in order to show the image, I simply call ImageData.show output image. Output image, remember, is this double array, this 2D array that we have here. That is where this window, when I hit compile and then I do Greer.png. That is what this does. And from here, you can actually save the file. One note is when you save this file, you want to save the file as a PNG. If you save the file as a JPG file, a JPG will actually be compressed. In this assignment, because you're hiding a message inside of the picture, you don't want any compression. JPG, especially on Windows, will do pretty significant compression, and you will lose the message. So always save this file when you show it as a PNG for this homework. The next thing I want to show, though, is that using a nested for loop is not necessary. Nothing wrong with it, but you may find it easier in this assignment to do a single for loop. And the way we can do this is we can take advantage of the fact that our image is rectangular, and instead of I being, say, a row and J being a column, we can just number all of the pixels. And the total number of pixels in the image is just simply the width times the height. So if the width were, say, 200 and the height were 250, we would have 50,000, pixels in this image. So I would loop from 0 to 50,000. From there, the row number of each pixel, if this works, starting with the top left, it's 0, and then if you move over a little bit, it's pixel number 1, then pixel number 2, then pixel number 3, so on, all the way down to pixel 50,000. Well, in that case, the row can be acquired by just I divided by width. Remember, this does integer division, and so the decimal place will be dropped. But then the column number is just the remainder of that division, or the modulus function. From here, we can reverse the picture by just height minus 1 minus row. The reason we have to have the minus 1 here is that there is no row with the ID height. Rather, height minus 1 is the last row. So if we want to put row 0 at the bottom, this is how we write it. Same is true for the column, and then we store it. So this is uploaded onto Piazza as well as this video, as well as the Wilger picture I'll upload so you can test it yourself. One thing I do want to note is we can modify the picture in other ways. For example, I could say right now that, let's just say output image 0, 0, 0 equals, and then I could do something like, since this is an integer that represents a color, I can do 255. And now remember that the way these colors are set up, we have 8 bits for blue as the least significant bits, 8 bits for green as the next most significant, and then red is the most significant, also 8 bits. And so 255 will only cover bits 0 to 7. If you wrote out 255 in binary, it would look something like 1111, 1111. 8 ones. So that's the highest value we can have for a color. And so because this only reaches in the blue, this color will be blue. And if I change the top left pixel to that, we can zoom on it and you'll see that happens. I'm also going to do output image 0, 1 equals 256. Now you may be thinking, okay, so this is going to be slightly more blue, right? Well, what happens is when we have 256, that's no longer all these ones. Rather, it's a 1 followed by 8 zeros. And so in this case, these 8 bits are still all of the values of blue. But this is only one value of green, which is not very much green at all. So much so that this will appear black. To give you an illustration of why this is relevant, if I then change the next pixel, output image 0, 2, to be equal to 257, that is, I change this last bit to 1, you'll see that it actually won't look different. So we're going to compile. We will run with Greer.png. And then I'm going to go ahead and save this image in order to look at it more deeply, so Greer flip.png. And then from there, I will find that file, and I'm going to open it in Paint just to show you that I can zoom way in. And here you can see the 3 pixels I made up here in the top left. So you can see right here, there's a blue pixel, and that pixel is the pixel that we turned blue. And then next to these two black pixels, these were pixels that are technically different colors. They're both very close to black, as I mentioned, but they have one value of blue off, and you really cannot see the difference. And that's the goal of this assignment, is that you can hide, because you can't see the difference in the color, you can hide in that one's place, in that last value of integer, bits that are relevant to a message. So with that, I hope you found this helpful. Best of luck on homework 8, and actually, I'll do the LFSR videos separate. That way you can watch them both separately. So best of luck. Take care.